Hello, this is Miss Prater, your Algebra 2 teacher, and I am going to do a short review on Unit 2. This slide also says 2.13 Part 2, but there's a separate video for that 2.13 Part 2. There's a separate help video. So I am going to just go straight to the first question. And it says, what are the coordinates of the hole in the graph of the function f of x equals x squared minus 9 in the numerator on the top and x minus 3 on the bottom? So when we're finding a hole, the first thing we have to do is we have to factor the top. So the top factors into x plus 3 times x minus 3. The bottom is already factored. If you have forgotten how to factor x squared minus 9, we use the formula a squared minus b squared. And so for the problem x squared minus 9, a would be the square root of x squared, which is x, and b would be the square root of 9, which is 3. And then we follow the formula, a plus b, so x plus 3 times a minus b, so x minus 3. So that's how I got this numerator. Holes are going to occur in your graph anytime something in the top cancels with something in the bottom. So that means there's a hole. So I can go ahead and jump down here. Let's go ahead and simplify this out. So this is going to simplify out to be x plus 3. So now my function is just x plus 3. My hole occurs where that binomial canceled out. So you say what canceled out? X minus 3 canceled out. You set that equal to 0. You solve for x. So there's a hole in the graph, a literal hole in the graph, okay, where x is equal to 3. They do want the ordered pair here, so you just have the x value, but you don't have the y value. So to find the y value, you do f of 3, and you put 3 in wherever you see an x. And then you work that out, and you find out what the y value is when the x value is 3. So that means my y value is 6. So there's a hole in the graph at the ordered pair 3, 6. So if I go to the right 3 and I go up 6, and I find that ordered pair from the origin, this would be the y-axis and the origin. You go right 3 and up 6 to get to this ordered pair. There would be a hole in your graph. You do have to factor to be able to find holes in the graphs. Number 2 says, what are the equations of the asymptotes? So anytime we're talking about asymptotes, let's just do a quick review. We have vertical asymptotes, and I'll abbreviate those VA. Vertical asymptotes are always in the form of x equals a number, because that's the form of a vertical line. Horizontal asymptotes would be in the form of y equals a number, because that's the equation for horizontal lines. And so I just took this equation and I put it into my TI-84. So this is what my y equals looks like in my TI-84, and then this is what my graph looks like. And I can see pretty good that there is a vertical asymptote. This is -1, this is -2, this is -3. It looks like there's a vertical asymptote running right here between the two branches. So that would be at x equals -4. So I'm going to check that one. And then it looks like there's a horizontal asymptote. 1, 2, 3, 4, 5, 6. There's a horizontal asymptote running through where y is 6, -6. So this line is y equals -6. This line is x equals -4. So my horizontal asymptote would be at y equals -6. So then I would choose this one. They're going to try to trip you up with some of the other answers. So that's why it's important that you know vertical equations are always x equals a number. Horizontal equations are always y equals a number. Number 3 says, what effect does replacing x with x minus 4 have on the graph of f of x? So again, on this problem, I used my TI-84. In the y1 equation, I put the exact equation that they gave me, absolute value of x minus 6 plus 2. In the second equation, I did In the place of the x, I substituted in x minus 4, but the rest of the equation stayed the same. I hit graph, and then I've got my blue graph, and I've got my red graph. So it's wanting to know what happens to the red graph. Okay, we started with a blue graph. We substituted x minus 4 in for x. What happened from the blue graph to the red graph? So we can definitely see the graph is shifted to the right. The red graph is shifted to the right. So we know left is not going to work. So we're going to click shift to the right 4 because we went 1, 1, 2, 3, 4. And then the graph is not moving up or down. And it didn't get shifted to the right 10. That's not true. So we would check the last one. I will show you really quick how to get the absolute value on your TI-84. Sometimes that can be tricky. Let me pull up my calculator real quick. The absolute value on Desmos, if you're using Desmos, is right above the ABC button on the keypad on Desmos. I can show you that also really quick. So when you're in your y equals and you're wanting to do absolute value, you have to hit the math key, and then you have to arrow to the right one time to get to number, and then ABS will be the first thing, and then your little absolute value bars pop up. Make sure if you've got anything inside that you put those inside, and then you hit the right cursor, and then if there's anything outside, you put that outside the absolute value. If you are working in Desmos and you want to do an absolute value, you're going to pull open your notepad down here, and absolute value is located right here. So you would do F X equals, and then you would hit that absolute value, and you would put, whatever's in the absolute value. You would arrow over to the right, and if you had anything outside, you would put it outside. Number 4 says, what is the domain and the range? So quick reminder, domain are your X values. Range are Y values. And again, I just plug this equation into my Y1 and my TI-84, and then I hit graph, and I have a beautiful picture of this. So this graph has a closed circle at this end, and it fills up my viewing window, so I know that it's going to go on forever and ever here. The reason I know that I don't have any points over here in the second quadrant is because this is where x is negative, and if we put a negative number in for x and we take the square root, we get imaginary numbers and not real numbers. So that's how I know that there's a closed circle on the left end, and then there's an arrow on the right end. So if we're talking about our x's start at 0, and then they travel forever to the right. So our domain would be 0 to infinity. Our y values are going to start up 1, 2, 3, 4, 5 at positive 6, and then the graph is going to continue to rise to positive infinity. So our range is going to be 6 to infinity. Number 5, the given function f of x and g of x are given. Describe the transformation from f of x to g of x. So I have my f of x and my y1 and my TI-84, and I have my g of x and my y2. So they're asking what's happening from the blue graph to the red graph. Well, the first thing that I notice is the blue graph is opening up and the red graph is opening down. When that happens, that is a reflection over the x-axis. That's happening because the g of x has this negative out in front. That's always going to flip your graph over the x-axis. So I know that's happening, okay? I also notice that the blue graph starts at 0 on the x and y axis, but the red graph starts at 2. So that means there's been a shift up. So I'm going to look for the answer that says reflect over the x-axis and shift up to, reflection over the x-axis and shift up to, vertically shift, meaning up or down, but they're saying up. So definitely use your TI-84 or Desmos, get you a good visual of what's going on. If you can't do it without the graph, definitely use the graph. Number 6 is saying, given the piecewise function, f of x, find f of 2. So this is your directions. Find f of 2. So you have to realize there's two pieces. This is a piecewise function. There's two pieces. They're wanting us to find f of 2. So we have to look at the inequalities here. If we use the first piece, we only use it when x's are less than 2. So like 1, 0, negative 1, negative 1.5. And we only use the second piece when x's are greater than or equal to 2. So since they're asking us to find f of 2, we would use the second piece of our piecewise function because 2 is greater than or equal to 2. And so that means where we see x, we're going to substitute in a 2, and then we're going to work out the problem. And then whatever we get is the answer. So what that really means is that I have a point on that second piece. When x is 2, it forces y to be 0. But they're not asking for an ordered pair here. So the OHS, don't put an ordered pair in unless they specifically say ordered pair. So they want to know what f of 2 is equal to, and it would be equal to 0. Same thing for this one. I have another piecewise function. I have two pieces, so we'll number those piece 1 and piece 2. They're asking me to find f of negative 8. So let's take a look at the first piece. The first piece is only for x's that are less than negative 6. The second piece is only for x's that are greater than or equal to negative 6. And if I'm trying to find f of negative 8, f of negative 8 would definitely be less than negative 6. So I'm going to use the first piece, which is the absolute value of x plus 3. And then I'm going to find f of negative 8. So that means wherever I see an x, I'm going to plug in negative 8. The absolute value bars first act as parentheses. So you'll do what's going on inside. That's going to give you negative 5. And then you'll take the absolute value of negative 5. And you'll get positive 5. So positive 5 will be your answer. And number 8. I think this is the last one. It says, what is the domain and the range? So again, domain are your x's. If you ever get confused, I think about alphabetical order. Range is your y. So domain comes before range in the alphabet. X comes before y. So I took this equation and I put it in Desmos. This is a Desmos graph. You could also use your TI-84. The first thing that I'm going to point out is we do have a vertical asymptote. This looks like these are 2, let's see, 2, 4, 6, 8, 10. Looks like there's a vertical asymptote right here at 3, where x is 3. So I have a vertical asymptote, but x equals 3. That's going to affect my domain. Okay, we'll just kind of start with that. So our x's are going to go from negative infinity, because this arrow is going forever, and they're going to go up to 3. Okay, we don't have any x's that are 3 because we have a vertical asymptote at 3. So that means I don't have any points where x is 3. I jump over that vertical asymptote, and then this branch, the x's are going to go from 3 to infinity. So my domain is going to be this one. Negative infinity to 3, parentheses, not bracket, because I don't have any 3's anywhere on either piece of the graph, and then union. And then on the right-hand side, we're going to go from 3 to infinity. On my range, it looks like this is 2, this is 4. This is just a coincidence, but I also have a horizontal asymptote at positive 3. So that's y equals 3. So my range is going to go from negative infinity up to 3. And then jump over there and then go from 3 to infinity. Not all the time do I have the same range as I do my domain, but on this one I do. All right, hopefully this was helpful. If you are getting ready for the end of the semester, remember you can always read over your notes, rewatch your class recordings on other sections other than this one, which is just the review for Unit 2. There's also helpful videos in my Bitmoji Classroom, which is under content. And then you can always email me for help. So good luck. Hopefully this will help you get through anything from Unit 2.